In this presentation, I'll be explaining 555 timer and its internal block diagram and application of 555 timer as Astable multivibrator. Coming to 555 timer, it is an 8-pin IC and it is highly stable device for generating accurate time delay. That is for as a monostable mode or for oscillation. It can be astable mode. It can produce continuous square wave using as an oscillator using in astable mode, or it has a time delay circuit in the case of monostable mode. For 555 timer can be either it can be used in monostable mode or an astable mode. And in this presentation, I'll be concentrating in the astable mode of operation of 555 timer. Therefore, a 555 timer can provide time delay ranging from microseconds to hours that can be provided by using monostable mode. In astable mode, it can work as an oscillator. Continuous square wave can be generated using 555. Basically, 555 an IC. It is an IC. It is an 8-pin IC. Therefore, pin number 1 is a ground, 2 is the trigger. I will be explaining later. And 3 is the output where we are getting the output. And 4 is the reset pin. And control voltage, that is pin number 5, and here threshold, that is number 6, and 7 discharge, and number 8 VCC. So this is an 8-pin IC 555 timer, and the application of 555 timer is different types of applications. It can be used as an oscillator, it can be used as a pulse generator, ramp and square wave generator can be generated, and mono-shot multi-vibrator it can be used. It can be used in burglars alarm, traffic light controller. The wide application is the 555 timer. Therefore, it can be operated either in monostable mode or an astable mode. Let us see the functional diagram of 555 timer or internal block diagram of a 555 timer. Therefore, the function diagram that consists of first 2 comparators are there. That is upper comparator and lower comparator. There are 2 comparators are inside 555. Second, 3 5K resistances are there. There are this voltage VCC to ground. This voltage is divided by 3 1/3 voltage using 3 resistors inside. This is the inside IC. 5 kilo ohms resistors are 5 kilo ohm 3 resistors are there. That's the second thing. And third is there's an RS flip flop. This is a reset set flip flop. That is the there's a third component. Therefore, 2 comparators, 3 resistors, and 1 flip flop, and 2 transistors are there, Q1 and Q2. This is a Q1 transistor, another transistor Q2. This is a NPN transistor. This is a PNP transistor. These are the 2 transistors are there. And one more is that one power amplifier that is using as an inverter. So this is whatever the signal, if it is high, here will be low. If it is low, it is high. This is an inverter power amplifier. So these are the things that is inside the 555 IC. 2 comparators, 3 fixed value of 5K resistances, 1 flip-flop, 2 transistors, 1 NPN, 1 PNP, and 1 inverter or power amplifier. And there are 8 pins are there for 555 IC. And pin number, say here 8 is the VCC, pin number 6 is the threshold, and pin number 5 is the control voltage that can be applied, a voltage can control, and 2 is the trigger input, and 7 is the discharge, and of course here ground is there, that is the pin number 1 is the ground, and 4 is the reset pin, and 3 is the output pin. Therefore, this is an 8-pin IC, and this is the internal block diagram or functional diagram of a 555 IC. Now there are 3 5 kilo ohms internal resistance, like here 3 resistance are there. Then this voltage VCC will be divided as, here the voltage will become equal to 2/3 VCC, and here the voltage will become equal to 1/3 VCC. Therefore, this voltage VCC is divided into 2/3 VCC and 1/3 VCC here using 3 equal resistance of 5 kilo ohms. Providing a 2/3 VCC to the upper comparator. Here you are getting a 2/3 VCC to the upper comparator, and also 1/3 VCC to the lower comparator. Here 1/3 VCC is to the lower comparator. That is done by 3 equal 5 kilo ohm resistances, equal resistance of each 5 kilo ohms, and 1 by 3 VCC to the lower comparator, where VCC is the supply voltage. VCC is applied at the pin number 8, that is the supply voltage. Pin number 8 is the supply voltage VCC, and pin number 1 is the ground. Between them, 3 equal resistors are connected internally, and this is equal to 2 by 3 VCC connected to the upper comparator, and this is 1 by 3 VCC connected to the lower comparator. Therefore, these two voltages, 1 by 3 VCC and 2 by 3 VCC, fix the necessary threshold voltages of the comparator, because the change in comparator stage is decided by, or the threshold value is decided by these two voltages, 1 by 3 VCC as well as 2 by 3 VCC. This is for upper comparator and this is for lower comparator. Normally, it is recommended to connect a capacitor of 0.01 microfarad between the control voltage terminal, that is pin number 5 as well as ground. Normal in working here, there will be a capacitor of 0.01 microfarad between pin number 5 and the ground, pin number 5 and the ground. And to bypass the noise from the supply, in order to bypass the noise from the supply, you will be connecting a capacitor between number 5 and the ground. So this is the internal diagram of a 555 or function diagram of a 555 timer. Continuing the 555 timer working of 555 timer, and here in stable state, that is what the output of this Q bar will become. Output of Q bar is high, that is here Q bar is high in the stable state, or we can say that this is an inverter, so that output will be low. Therefore, in stable state, Q bar will become high, that is Q bar means output of the flip-flop. Q is the output and Q bar is the complement of that one. That will be high in stable state, or this is high means output is become low. That is the case when this is in the stable state. Now this makes the output low, because Q bar is high means this is an inverter, output will become low because of the power amplifier which is acting as an inverter. Now when a negative going edge is coming at the trigger pins, when a negative going edge signal is applied at the pin number 2, this is a trigger input, and a negative going edge, if once this voltage is going less than 1 by 3 VCC, because the voltage at this point equal to 1 by 3 VCC. Therefore, once this voltage is going, once the negative edging triggering voltage is going less than 1 by 3 VCC, then the output of this one will be changing to high, because it's a comparator in which to the plus terminal we have 1 by 3 VCC. Once this voltage is going less than 1 by 3 VCC, negative going 1 by 3 VCC, this will become high. Or when this is high, set pin will be high. As set pin is high, output Q will become high. As Q will become high, Q bar will become low. As Q bar is low, that is Q bar is low means that this pin will become low. Or Q bar is low, this is an inverter, output will become high. That is why when the trigger input is going a negative value, a negative change, that is a negative going a trigger, triggering at the pin number 2, as this voltage is going less than 1 by 3, here this will become equal to 0 and output will become changing to 1, that is passes through 1 by 3 VCC, that is at the negative going edge of the trigger. As the trigger passes through 1 by 3 VCC, output of the lower comparator, this is the lower LC, is the lower comparator, output of the lower comparator will become high. As the reset pin is high, here's our reset pin, set pin. As the set pin is high, Q will become high and Q bar will become low. That is, as the output, as passes to 1 by 3, the output of lower comparator goes high, and this sets the flip-flop, meaning that Q will become 1 and Q bar will become 0. Q will become 1 and Q bar will become 0. Or Q bar when it is low, this is an inverter, output will become high. And when the another pin is to control is the threshold pin, pin number 6. As the pin number 6 voltage is going about, this voltage is 2 by 3 VCC. This voltage is 2 by 3. As the pin number voltage 6 is threshold voltage is going about 2 by 3 VCC, here this pin will become high. Comparator, upper comparator output is high. As this is high, this is a reset pin, R pin. As reset pin means that Q will be reset or Q will become 0 and Q bar will become 1. That is, Q will become 0 and Q bar become 1. Therefore, when the threshold voltage at pin number 6 passes 2/3 VCC, output of the upper comparator that will become high and resets the flip-flop, making Q will become 0 and Q bar become 1. As Q bar will become 1, output will be again coming back to 0. Therefore, that is the way in which is working these pins like trigger pin as well as reset pin. As trigger pin goes less than 1/3, that will be setting and will be getting Q equal to 1 and Q bar equal to 0 and output equal to high. When the threshold voltage is going above 2/3 VCC, then here it will become reset and Q will become 0, Q bar equal to 1 and the output will become 0. Therefore, the reset, another pin is there, what's called the reset pin. The reset pin, pin number 4, provides a mechanism to reset the flip-flop. You can externally reset the flip-flop by providing a signal to the reset pin. Therefore, if reset pin is not used, normally in the circuit, so when you are designing a circuit diagram, reset pin will be connected to the VCC. And transistor, if reset pin is not used, that is connected to the VCC. And transistor Q2, that is this transistor, PNP transistor, that is acting as a buffer to isolate the reset pin from the flip-flop. That is a function of this transistor. Anyway, there are two transistors. One is the Q1, another is the Q2. This is acting as a buffer to isolate the reset pin from the flip-flop. Now let us see the astable operation of 555. An astable multivibrator has two temporary or astable states. Output of the circuit is automatically changing from one state to the other without any external triggering pulse. Therefore, output will be changing from high to low, low to high without any external signal. Automatically, you will be getting an output of oscillate, as it's working as an oscillator. Or it is certain duration, it will be high, certain duration, it will be low. Again, it is high, it is low. Like that, you will be getting an astable output. A continuous score. It's a score or a rectangular wave as such. On period and off period you can control, and you can get a rectangular wave output at the pin number 3. No triggering is required in the case of astable operation. Once circuit is fired like it, automatically it will be generating a score wave like this one. Now in this one, the connection diagram is given. Pin number 8 and 4 is connected to the VCC, and the pin number 3 is the output where we are getting the output, and pin number 5 and here, and that is connected to the ground through a 0.01 microfarad, and this is the main circuit where it is working. In that one, between VCC and pin number 7, discharge pin, that is pin number 7, that is a resistance of here we are connecting RA, and another resistance between 7 and here 6, the trigger signal, another resistance RB is connected, and there's a capacitor is connected, this one. Suppose this is the method of connecting, and between pin number 1 is grounded, between pin number 2 and 6 that is shorted. So this is a circuit diagram of an astable operation. I will be explaining the working in the next slide. And here the internally, if you see this, the same thing circuit, that is internal diagram also shown here with the upper comparator and lower comparator. Internally there are resistances, as I already explained. Flip-flop is the two transistors are there, and there is output. There will be a buffer. So an inverter is there. This is the output. Power amplifier inverter is there. Here you are getting the output. Pin number 3 is there. And as per this one, you are connecting the resistances like RA, RP, and C during this one. And now we can see this is a function diagram of an astable multivibrator. And this is the multivibrator pin diagram and its connection diagram. And including the internal or function diagram, this is the astable mode of operation of a 555 timer circuit. Now let us see the working of astable multivibrator using 555. Already the circuit diagram already seen in the last slide. The same circuit diagram with a functional diagram it is shown here. And here the pin number 8 is the VCC. Between pin number 8 and 7, that is This is a discharge pin, and between 7 and we are connecting a resistance RA, and between 7 number, pin number 7, discharge pin, and threshold pin 6, another resistance RB is connected. So this is RA and this is RB, and then pin number 6 and 2 are shorted. That is 2 is the trigger and 6 these are shorted, and from that shorted pin we are connecting another capacitor externally between ground, that is pin number 2 and 6 are shorted. From that one you are connecting a capacitor C, that is grounded. Therefore that is the circuit diagram. RA, RB and that C, that is externally connected. And now let us see the working of this one. Now when the power supply VC is connected, that is we are applying the voltage VCC, the external timing capacitor, this is the capacitor that you are externally connecting. External timing capacitor charges towards VCC through RA and RB with a time constant RA plus RB into C. Therefore, when a supply voltage VCC is connected, this capacitor is getting charged through RA, RB with a time constant RA plus RB into C. Therefore, the capacitor is getting charged through this path. And once, as you see that one, if this voltage is just crossing 1 by 3 VCC, you see if it is 1 by 3 VCC, if this is equal to say more than 1 by 3 VCC, here this voltage here, this is equal to 1 by 3 VCC, and this is the output is equal to, that is here, that is if it is equal to say 1 by 3 VCC, output will become equal to Q equal to 1, that is Q equal to 1 means it will be setting, or if this voltage, that is here this is equal to setting to 1, Q will become 1, and as Q will become 1, Q bar will become low. As Q bar will become low, output is become high. Therefore, as this during from this one, as the voltage is going from 1 by 3 VCC, the output is equal to Q equal to 1 and Q bar equal to 0. Then again the capacitor is charging through again RA, RB, and through the time constant RA, RB, RA plus RB into C. And once that capacitor voltage reaches to, because that is connected to the upper comparator, and once this capacitor voltage reaches to here, this voltage equal to 2 by 3 VCC, going just above this 2 by 3 VCC at this point, that point here, then here R will become high. When R is high, reset pin is high, meaning that Q will become 0 or Q bar will become 1. As Q bar is 1, the output will become going 0. Therefore, as this capacitor voltage reaches to that 2 by 3 VCC, the output is changing from high to low. That is, this output will be changing from high to low. And at the same time, we can say that this is low, it means that this will become high. As this is going high, this transistor is getting turned on, because Q bar is high, this transistor NPN transistor gets turned on. Or as this is getting turned on, here this capacitor here, that is connected through RB. Therefore this transistor, this pin is connected to this one. Therefore this capacitor will be discharging through RB and through this transistor, and that is to be grounded. Therefore the discharging of capacitor taking place, the already charged capacitor up to 2 by 3 that is getting charged, and after that one capacitor discharged through this path, through this one, through RB, and then through the transistor, and that is to the ground with a time constant RB into C. Therefore the discharging is the time constant equal to RB into C, that is discharges. And as this capacitor voltage just going less than 1 by 3 VCC, or if this voltage is just going less than 1 by 3 VCC, or this voltage will be just above that one, then this point is again going high, or set pin goes high. As set pin goes high, here the Q bar will become low or Q will become high. Q bar is low or Q will become high, or Q bar is low, the output is again changing to 1. Or at the same time, this is equal to low, means the transistor is getting turned off and the output is high. That is what is happening at this point. Once the voltage is just crossing 1 by 3 VCC, again the output is changing to high. Therefore, this is the way in which this is working. First, capacitor is charged through RA, RB with a time constant RA plus RB into C. Once that voltage reaches to 2 by 3 VCC, upper comparator is turned on, and reset pin is high, or output is 0, or Q bar is equal to 1. As Q bar is equal to 1, output is equal to 2 by 3 VCC, output is equal to going 0. That is happening at this one. And then capacitor discharger through RB, that is through the transistor, the capacitor is discharging with the time constant RB into C, and that discharge path from 2 by 3 VCC to 1 by 3 VCC. Therefore, the capacitor voltage, if you plot, the capacitor voltage will be changing from 1 by 3 VCC to 2 by 3 VCC. At that time, the output will be high, and then again that will be discharging, and with the time constant RA plus RB into C, and the discharging, during the discharging part, the transistor is conducting, output is low, and with a time constant RB into C. That is the discharging part of the capacitor. So this is the capacitor voltage, that is the voltage at this point, and this is the output voltage that is available at the pin number 3. Therefore, when capacitor voltage is equal to be precise, just greater than 2 by 3 VCC, the upper comparator triggers so that output becomes 0 and Q bar will become 1. That is at this point, that is when it's 2 by 3, that is by, and output will become low, and this in turn makes the capacitor this transistor here this Q1 to turn on, and the capacitor C starts to discharge through RB with a time constant RB into C, and that is the discharging path from 2 by 3 to 1 by 3 VCC, 2 by 3 VCC to 1 by 3. During that period, output will be low. Then again, when it is going just below 1 by 3 VCC, this will become high. Again, that will become Q set is high, Q is high, or Q bar is low, and then output is going high. Therefore, again that output goes high. Therefore, this is the output diagram, and this is the voltage across the capacitor. Capacitor voltage changes from 1 by 3 VCC to 2 by 3 VCC charging, 2 by 3 VCC to 1 by 3 VCC discharging. Continuing the working of Astable multivibrator, as I already explained, the capacitor is charging during from 1 by 3 VCC to 2 by 3 VCC. During that period, you will be getting a high output voltage, and from 1 by 3, 2 by 3 VCC to 1 by 3 VCC discharges, and a charge that will be discharging through this RB and through this transistor, and that will be discharging. And during the discharging, during discharging time of the C, as it reaches just to be precise, less than 1 by 3, as this voltage is going just below 1 by 3 VCC, this will become high, or S is high, or Q will be high, or Q bar is low, the transistor gets turned off. Lower comparator to trigger S equal to 1, R equal to 0. That makes the output Q1 high or Q bar equal to 0, and the output changes to high. That output will be changing to high. This capacitor periodically changes, charges and discharges between 2 by 3 VCC and 1 by 3. 4. Capacitor will be charging from 1 by 3 VCC to 2 by 3 VCC, and then again discharging from 2 by 3 VCC to 1 by 3 VCC. And during the charging, output voltage will be high. During discharging, output will be low. And the charging time constant equal to RA plus RB into C, and the discharging time constant is equal to RB into C. Continuing the Astable multivibrator working, the same circuit as shown redrawn. Another one here, as we have seen. 555 AC. This is the same circuit, Astable multivibrator, and just a VCC is connected at pin 8 and 4 is shorted, and we are applying the VCC, and RA is and RB is the resistance, and between the 8 pin and 7, this is the discharge pin 7, and between RA is connected, and another resistance RB is connected between 7 and 6. And threshold pin is there, and the RB is connected, and 6 and 2 are shorted externally, and that pin you are connecting a capacitor C. So this is the circuit that is we are externally connecting, and of course there is a capacitor between 1 and ground. We will be connecting external capacitor, and here this is the output is available at the pin number 3. Therefore, this is an Astable multivibrator in which the during the charging process of the capacitor, that is capacitor's voltage is changing from 1 by 3 VCC to 2 by 3 VCC. That is, here the capacitor voltage is charging from the VCC through RA through RB, and this is a charging process. RA, RB and C, the capacitor voltage charges. Then capacitor voltage is charging from 1 by 3 VCC to 2 by 3 VCC, and during that period you will be getting a high output voltage. And once the voltage at this point, the pin at this point is reaching to the here 2 by 3 VCC, and once that voltage is getting the 2 by 3, once this voltage at this reaching to the 2 by 3 VCC, Then the capacitor discharges. The capacitor discharges through this one, and through this transistor, that will be discharging with a time constant RB into C. Same circuit as shown here, and the charging is from through RA and RB and C, and discharging is through RB. And during the charging period, output voltage will become high, and during the discharging of the capacitor, the output will become low, so that we can control the charging time constant as well as discharging time constant, and so thereby you can control the time period of during the output is high or and output is low. Therefore, this is the working of an astable multivibrator using a 555 IC.